Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about ArrayList, one of the most commonly used implementation classes of the list interface. So by the end of this video, you will understand what ArrayList is and its features, how it works internally, its commonly used methods, and when you should use it. So let's get started. So ArrayList is a class. Okay, ArrayList is a class that implements the list interface. So we can say it is a class that implements the list interface, or in other words, implementation class of the list interface. Okay. So it is a class that implements list interface. It stores elements in insertion order. That means it maintains insertion order. It allows duplicate elements and it supports index-based operations, and it automatically grows or shrinks as elements are added or removed. If elements are adding, then it will grow. If elements are getting removed, then it will shrink. So dynamically it is resizing as and when required, needed. Okay. So we are learning what ArrayList. In the hierarchy, where does it belong? So iterable is what? Parent interface, then collection interface, correct? Then collection, we have again three sub interface. What are those? List, set, and queue. Okay. In list interface, we have implementation classes. What are those? ArrayList, which we are studying. Okay. And linked list is another implementation class, and vector. So currently we are studying ArrayList, that is implementation class of list interface. That is first point. Implementation class of the list interface. Now, why use ArrayList? So arrays have a fixed in size. Okay, we are talking about arrays first, then we will talk about ArrayList. Okay, so we are seeing problems with arrays. Like for arrays, they have fixed size. Okay, so once an array is created, its size cannot be changed, and ArrayList solves this problem. How? By resizing it automatically. Resizing it automatically. Okay, it will resize automatically as and when required. If it is elements are getting removed, it will shrink. If elements are getting added, it will increase the size. Okay, so dynamically it is changing. So that's how fixed size problem of array is resolved by ArrayList. And ArrayList, it also provides many built-in methods. Okay, many built-in methods that make working with data much easier. Okay, so these are the like basic difference between the array and the ArrayList, and remaining difference are it is difficult to add or remove elements. Okay, insertion and deletions are quite easier with the built-in methods. Okay, let's see some feature of ArrayList. So it preserves the insertion order. Okay, what does it that mean? Means the elements insertion order will be remembered. If we are inserting in a particular order, in that order the elements will get retrieved. Okay, and it allow duplicate and null values. Okay, null values. It supports index based operation. That means let's say we have elements 10, 20 and 30 at index 0, 1 and 2, and we want to fetch the values on the base of index. We can perform those operations since it supports index based access, and it grows dynamically, okay, and provides fast access to the element. Okay, if in an application we are fetching data very frequently, so those kind of situation we should go for ArrayList, because it is very fast random access based on the index. Okay, so how ArrayList works internally? Okay, how ArrayList works internally. So ArrayList works internally means internally ArrayList is backed by a dynamic array. Okay, ArrayList. Okay, ArrayList is dynamic array. Why we are saying dynamic array? Because what it will do? It will copy element. Okay. Okay, let's take an example so that we'll have. So let's say we have 10 elements. Okay. And we created a large array. Okay. And let's say it will copy old element and adds new element. So when internal array becomes full, ArrayList creates larger array and copies all existing elements into the new array and then adds the new element. So this resizing process happens automatically, so you don't need to manage memory yourself. Okay, so I hope you understood. So let's say initially we were having 5 elements. Okay, now we want to store 5 more elements, then size will increase to 10 elements. How? So it will create a one larger array of size 10. Earlier it was 5 elements only. Okay, now it will copy old elements. That means those 5 elements will get copied here, and after copying the 5 old elements into the larger array, it will again add new element into the large array. That's how dynamic array is working internally, and we don't need to do anything by ourselves. So that is done by the dynamic array. Okay, and who is using dynamic array? ArrayList. ArrayList is using dynamic array. So this is the bigger advantage of using ArrayList over array. Okay. Now, capacity and size. So a common interview question is the difference between capacity and size. So capacity is the total number of elements the internal array can hold before resizing. That means number of elements the array list can currently hold, that is capacity. But what is it is actually holding, how many elements is actually stored, so that is size. So let's say it has capacity 10, but currently the number of elements present in the array list is 4, so size will be 4. Okay, so size is the number of elements currently stored in the array list, that is the size. Okay, so in this example, if the capacity is 10 but only 4 elements are stored, so the size will be 4. Okay, so ArrayList provides many useful methods. Okay, and some of the commonly used methods are, let's say, add to insert elements, get to retrieve elements. set to update elements, remove to delete elements, contains to search an element. Okay, for searching we can use contains, and size is to get the number of elements stored, is empty to check whether the list is empty or not, and clear to remove all elements. Okay, so let's see some advantages of ArrayList. Okay, so ArrayList offers several advantages. One of them is dynamically resizing. Just now we have seen the one example, right? So dynamically resizing, it automatically it will resize based on the number of elements. It is simple to use and fast random access. Why fast random access? Because of indexing. Okay, it supports index based operations. So due to index based operation, faster random access. Okay, it maintains insertion order and includes many built-in methods for working with data efficiently. Okay, so these are the advantages of ArrayList. There are some limitations of ArrayList. Let's go through that also. Okay, so although ArrayList is efficient, okay, for accessing elements, accessing means for fetching elements, but insertion or deleting elements in the middle, okay, in the middle can be slower. Why? This is because the remaining elements must be shifted to maintain the correct order. Okay, so whenever we want to insert or delete in the middle, it is kind of slower. Reason being, elements need to be shifted. How? Let's see an example. Let's say we have 4 elements A, B, C and D. Okay, and we want to remove this element V. Okay, removal is very easy. Okay, it removed, but after removal this space will be empty, right? So C should come here and D should come here. So there is shifting of elements. Okay, so that's why it is slower. And reason mentioned here, elements need to be shifted. Okay, so after, see, element shift left, so remaining elements must be shifted to maintain the correct order. Okay, so this is one of the limitation, and ArrayList is commonly used in real-world applications such as shopping cart, music playlist, book collections, movie list, and contact list. So these scenarios require ordered data with frequent access using indexes. Okay, the reason of fast access is indexing. Okay, now when should we use ArrayList? ArrayList is the right choice when your application performs more read operations than insertion or deletion. Why? Because fetching of data is faster in ArrayList. Why? Because of indexing. It can fetch data with the help of index very fastly. So if we want frequent reading of data, then we should go for ArrayList. Okay, and if your application frequently insert or delete elements in the middle of the list, then we should go for linked list. Okay, linked list is the better choice for insertion and deletion. We will see in the linked list example. So that's what last point, not ideal for the frequent insertion or deletion in the middle of the array list. Okay, so this point we have covered. Index based access is required, and this point we know order is important and duplicates are allowed in the array list. Okay, so we have seen this hierarchy. So we have covered list interface, and array list is one of the implementation class of the list interface. So we are reading this, we're reading about array list. We have seen between the difference between the capacity and size. So they have mentioned some of the like initial capacity, initial size, those things. Okay. Inherently thread unsafe means faster in performance. Okay. If it is inherently thread safe means somewhat slower in performance. So we are covering ArrayList as part of this video. So let's quickly summarize what we have learned so far. So implements the list interface. Okay. This is implementation class of the list interface. Class which is implementing list interface. So it uses a dynamic array. We have seen how dynamic array is created. Okay. So it will create one larger array and it will add some elements for increasing size. And for decreasing size, it will again create one smaller array and it will add less elements and remaining elements will get removed. So this thing will happen internally. We don't need to do anything from our side. So that is what it is, dynamic array. It maintains insertion order. It allows duplicate and null values. And it is faster because of index-based access. And automatic resizing, that is dynamic resizing, is available in ArrayList. So that's all for this video. I hope this tutorial helped you understand the concept of ArrayList in Java. Thanks for watching and I will see you in the next video.